So far, we've learned three ways to solve a quadratic equation. We can graph and see where the parabola hits the x-axis, or we can do factoring in Mr. Squiggly, or we can do quadratic formula to find the zeros. In all three of those methods, we need our quadratic equation set up like this. Something x squared plus something x plus c plus a constant equals 0. With the last method, the completing the square method, we have to transform this equation a little bit. When we're completing the square, we don't want an a value. I'm going to get rid of that for right now. If there is an a value there, we'll discuss what you do if there is an a. Now, from here, we want to get that constant away from the x's. So I'm going to use opposite operations to move the c, the constant number, over to the other side. So 0 minus c is obviously negative c. And over here, I'm going to be left with x squared plus something x. And I'm leaving a space because now we need to find what I call the magic number that will help us complete the square. Now, how we determine that magic number is you take your b value, cut it in half, and square it. And whatever I add there to the left as my magic number, I'm going to need to add to the right as well to keep the equation balanced. So b over 2 squared. Now let's take a look at how this works with an actual example with numbers for a, b, and c. We'll use this equation, x squared minus 6x plus 34 equals 0. If I want to find the zeros by completing the square, the first thing I'm going to do is move the 34 to the other side. Opposite operation to move it. So now I have x squared minus 6x, I'll leave a little space for my magic number, equals negative 34. Now to decide what that magic number is going to be, I'll do it off here on the left. So b is negative 6. I'm going to cut that in half, which is negative 3. And then I'm going to square that, which will be positive 9. That's going to be my magic number that I add to the left and to the right to keep that equation balanced. Now off on the right, we can just add these two numbers together. That would make negative 25. And over here on the left, the purpose of that magic number is so that we have this trinomial over here, x squared minus 6x plus 9, that is factorable. So we can unfoil this into x and x for the front. Numbers that times to positive 9 add to negative 6 are negative 3 and negative 3. And notice these two parentheses are identical. That is so that we can write this as a square. X minus 3 times x minus 3 is the same thing as x minus 3 all squared. And there I have completed the square. And this is still equal to negative 25. So now it's time to solve this for x to actually find what our zeros are. I can get rid of the square away from that parentheses by square rooting both sides. Square root, square root. So on the left, the square and the square root cancel out. It just leaves me x minus 3. Over here on the right, we're going to have to pound out that negative and make it imaginary. And the square root of 25 is 5, positive 5, but it could also be negative 5, because negative 5 times negative 5 makes positive 25. So there's our plus or minus like we would have in the quadratic formula. That's what's going to get us to our two zeros. And now to solve this for x, I just need to add the 3 to the other side. Generally, I put it here in the front, so I have the real number first, plus or minus the imaginary part second. And there's my two zeros, 3 plus 5i and 3 minus 5i of this equation, x squared minus 6x plus 34 equals 0. Now let's do one with an a value in the front. We have a 3x squared. So to get rid of that 3 in the front, we're going to divide everything by that 3. So that 3x squared divided by 3 will make x squared, plus 24x divided by 3 will make 8x, 12 divided by 3 will make 4, equals 0. And just by doing that, now I'm ready to do the completing the square process. So we're going to subtract the 4 to the other side. That'll leave me x squared plus 8x, leave a little space for the magic number, equals negative 4. So our magic number here that we're going to have to add to both sides of the equation, b is 8, so I'm going to take 8, cut it in half, which would make 4, and 4 squared makes 16. There's my magic number, plus 16, plus 16. Over on the right, we can combine those together. Negative 4 plus 16 makes 12. And on the left, here's that trinomial that we can factor into x and x. 4 times 4 will make 16, and 4 plus 4 will make 8. And there's those identical parentheses that should always happen when we're completing the square. So x plus 4 times x plus 4, I will rewrite as x plus 4 squared is equal to 12. And now I can get rid of that square from the parentheses by taking the square root on both sides. Opposite operations. Leaves me an x plus 4 equals plus or minus radical 12. Now notice radical 12 could be attacked here into radical 4 and radical 3, which is really going to be 2 radical 3. So this time our roots are not imaginary, they are irrational. And the last thing I'm going to do is subtract the 4 to the other side. So x equals negative 4 plus or minus 2 radical 3. And if we wanted, we could turn that into 2 decimal values and then compare those decimal values with our graph to make sure that they check out.